Hello, welcome. Today we enter a part of physics that does not easily allow itself to be explained. It only takes a few steps through the mysterious territory of quantum physics to realize that, deep down, the world does not work the way our everyday experience suggests. In the subatomic world, particles can exist in overlapping states, pass through forbidden regions, and respond to rules that do not fit within classical logic. None of this is an exception. It is the normal functioning of matter. What decides when this game of possibilities becomes one single result? Throughout this long journey, we will move through the central concepts of quantum physics, pass through the paradoxes that have most intrigued scientists, and understand how this territory influences everything from technology to the way we think about reality itself. But before we continue, I need your help. Please leave a like now, subscribe so you do not miss future videos, and share this story. What takes only a moment for you helps Cosmos for Rest continue to exist in an enormous way. Now, relax, close your eyes, and let science guide you. To begin our walk through this invisible realm, I'd like you to imagine the mindset of scientists at the end of the 19th century. At that time, there was an almost absolute feeling that physics was essentially complete, like a great precision clock whose gears had already been fully mapped and understood. The laws of Isaac Newton explained the motion of planets and the fall of apples with remarkable accuracy, while the equations of James Clerk Maxwell masterfully described light waves and electromagnetism. It seemed that all that remained was to refine a few decimal places and polish some minor details. And yet, you would not believe how much nature enjoys hiding its deepest secrets precisely in the corners where we think there is already enough light. The first sign that something was profoundly strange appeared when physicists tried to understand how objects emit heat and light when they are heated. Imagine a piece of metal being placed into a forge. As its temperature rises, it begins to glow with a deep red color, then shifts into orange, and if the heat becomes intense enough, it reaches white and even bluish tones. Classical physics, the same physics we use to build bridges and understand how a car engine works, predicted something bizarre and catastrophic about this phenomenon. According to the calculations of the time, a heated object should emit an infinite amount of energy at very short wavelengths, such as ultraviolet light. This became known as the ultraviolet catastrophe. If those laws had been correct, simply turning on a kitchen oven would flood the room with deadly radiation, which obviously did not happen. Can you imagine the frustration of brilliant minds trying to understand why centuries of mathematics seem to fail when faced with something as ordinary as the glow of a hot ember? Then, in the year 1900, a physicist named Max Planck decided to take a drastic step. In what he himself described as an act of mathematical desperation, Planck proposed something that would forever change our understanding of reality. He suggested that energy was not emitted or absorbed continuously, like an uninterrupted stream of water, but rather in tiny packets, in discrete and well-defined quantities. He gave these packets the name quanta. Take a moment to feel the weight of that idea. It was as if nature were not a smooth ramp along which energy could slide freely, but instead a staircase where you can only stand on one step or another, never in the empty space between them. Planck introduced a mathematical constant, now known as Planck's constant, a number so incredibly small that we do not notice its effects on the human scale, yet it governs every atom in your body. At first, not even Planck fully believed in the physical reality of these packets of energy. He thought they were simply a mathematical trick to make the equations work. But then a young Albert Einstein entered the picture in 1905. Einstein realized that this idea of energy packets explained another mystery that had scientists completely puzzled: the photoelectric effect. Imagine the following situation. If you shine light onto a metal plate, under certain conditions that light can knock electrons out of the metal, creating an electric current. The problem was that if light were purely a continuous wave, increasing the intensity of the light should give the electrons more energy and cause them to fly out with greater force. But that was not what happened. What mattered was not the overall brightness, but the color of the light. In other words, its frequency. Einstein proposed that light itself was made of these packets of energy. which would later be called photons. If an individual photon carried enough energy, it could kick an electron out of the metal. If it did not, then it did not matter how many billions of photons you threw at it, nothing would happen. It was like trying to knock down a wall by throwing millions of ping-pong balls at it instead of using a single cannonball. With this discovery, quantum physics stopped being a mathematical trick and became a real description of the foundation of the universe. Could you imagine the shock of discovering that light, something that seems so fluid and ethereal, is actually granular, as if it were an incredibly fine sand blowing through space? This shift in thinking was the first step into the mysterious territory we are exploring today. From that point forward, the idea that the world is solid and predictable began to dissolve. We discovered that the atom is not simply a miniature solar system, but a place where probability reigns. Electrons do not orbit the nucleus like planets following fixed paths. They occupy clouds of possibilities, leaping from one energy level to another instantaneously without passing through the space in between. These quantum jumps are the foundation of all chemistry and of life as we know it. Without this quantum strangeness, atoms would not be stable, and matter would simply collapse. We tend to think that things happen because of direct and mechanical causes, but at the quantum level, chance and uncertainty are the true rulers. Feel the calm that comes from understanding that, deep down, nature is not rigid. It is flexible, vibrant, and filled with secrets that reveal themselves only when we stop trying to measure it with the rulers of the macroscopic world. During those early years of the 20th century, great minds such as Niels Bohr, Werner Heisenberg, and Erwin Schrödinger began building the tools needed to navigate this sea of uncertainty. They realized that to understand the atom, it was necessary to abandon common sense and embrace paradox. Imagine trying to describe the color of a musical note or the weight of a thought. That was the sense of bewilderment physicists experienced. The quantum realm showed us that a particle can behave like a wave, spreading itself through space, and a wave can behave like a particle, striking a target with precision. This wave-particle duality is one of the cornerstones of our current understanding. It is not that the particle changes form. It is that it is both things at the same time, depending on how we choose to interact with it. Can you feel how deeply this challenges our notion of identity? Something can be both A and B simultaneously until a careful observation forces nature to make a choice. Every technology we use today, from the camera sensor in your phone to the processor inside the computer that allows us to have this conversation, depends directly on these concepts that emerged from a crisis in classical physics. The quantum world is not merely an abstract theory hidden away in dusty books. It is the pulsing reality that supports every star's glow and every heartbeat. As we immerse ourselves in this story, we realize that science is not built solely on certainty. It is built on the courage to question what seems obvious and to accept that the universe is far more extraordinary than our eyes can perceive. At this stage of our journey, we have established the firm ground upon which the mystery is built. We have stepped away from the safety of the predictable and begun floating in the waters of probability. Feel your breathing settle as you absorb the idea that the universe, in its most intimate essence, is made of light, vibration, and discrete packets of energy organizing themselves in an eternal dance of possibilities. There is no rush to understand everything right now. What matters is allowing this granular immensity to fill your thoughts with the beauty of the unknown. Now that we have laid the foundations of this invisible territory and understood how classical physics had to make room for something entirely new, I would like to invite you to notice how this quantum strangeness is not confined to sophisticated laboratories or complex calculations written across blackboards. In fact, you would be amazed to discover that our simplest daily routines and the objects we touch every day are, at their core, quantum machines operating in plain sight. Could you imagine that without the bizarre behavior of electrons, our modern civilization would simply have no electricity, no communications, and not even the sunlight that warms our mornings? It is fascinating to realize that nature never asked permission to be quantum. It simply is. And only very recently have we begun to learn how to move in rhythm with this microscopic world. Think, for example, about the device you may be holding right now. Or perhaps the one resting beside your bed. Inside every smartphone, tablet, or computer, there are billions of tiny switches called transistors. Can you imagine life without the ability to process information instantly? The transistor is the beating heart of the digital age, and it works only because of a purely quantum phenomenon known as energy band theory. In classical physics, an electron should behave like a marble encountering an obstacle. But at the subatomic level, electrons inside semiconductor materials such as silicon behave collectively, occupying allowed energy bands and leaping across forbidden energy gaps. When we control those leaps, we create the language of zeros and ones that powers all modern technology. Every message sent, every sound heard through a pair of headphones is the result of billions of quantum particles obeying laws that challenge our intuition from top to bottom. Yet the experience of this subject extends far beyond integrated circuits. Let us imagine for a moment the light that surrounds us. If you have ever walked into a supermarket and heard that familiar beep when a product passes through the checkout scanner, you have experienced the precision of a laser. The laser is one of the purest examples of quantum mechanics woven into everyday life. The word laser stands for light amplification by stimulated emission of radiation. Can you imagine what that means in practice? It means forcing an enormous crowd of atoms to emit light at exactly the same time, with exactly the same color, and in exactly the same direction. This is possible only because the electrons inside those atoms occupy very specific energy levels, like steps on a staircase, just as we learned from Max Planck. When an electron drops from one step to another, it releases a packet of light, a photon. In a laser, we cause all of those soldiers of light to march in perfect unison. Without the quantum understanding of light, we would not have vision correction surgeries, barcode scanners, or the fiber optic cables that carry the internet beneath the oceans. I would like you to feel the connection now between this world of the incredibly small and the living world pulsing all around us. We often think that biology and quantum physics belong to separate worlds. But nature is an engineer far older and far more efficient than we are. Can you imagine that plants, in the quiet stillness of a garden, perform quantum calculations every day? During photosynthesis, when a leaf captures a photon of sunlight, that energy must travel to the processing center of the cell, where it can be converted into food. If that energy followed a random path, like a person wandering lost through a maze, much of it would be wasted along the way. Yet plants make use of something known as a quantum walk. The energy explores all possible paths simultaneously through superposition and instantly selects the most efficient route. It is a level of precision that human technology still struggles to imitate. Every green leaf you touch during a morning walk is living proof that life itself is sustained by the mechanics of possibilities. Beyond plants, there are creatures that sense the quantum world in even more mysterious ways. Have you ever wondered how migratory birds can cross entire continents, flying over vast oceans without landmarks, and still arrive at exactly the same destination year after year? Modern science suggests that some species possess a kind of quantum compass within their eyes. There are proteins called cryptochromes that, when struck by light, create pairs of entangled electrons. These electrons respond to Earth's magnetic field in ways that classical physics cannot fully explain. It is almost as if the bird can perceive a superposition of colors or shadows, revealing magnetic north, allowing it to navigate across the globe guided by the entanglement of particles. Can you feel the magnitude of that idea? A tiny creature crossing storms and immense distances, connected directly to the planet's magnetism through an invisible quantum effect. And if we lift our eyes toward the source of all our energy, we discover that even the glow of the sun depends on a phenomenon that should not happen according to older physics. At the heart of the sun, hydrogen atoms fuse together to create helium, releasing a colossal amount of energy. The problem is that the temperature and pressure inside the sun, although incredibly high, are still not sufficient to overcome the electrical repulsion between atomic nuclei. They should repel one another like two magnets, facing each other with identical poles. But thanks to the quantum tunneling effect, a particle has a small probability of passing through that energy barrier, as if it were slipping through a hidden tunnel inside an otherwise impassable mountain. Without that tunnel, the sun would never ignite, and the solar system would be a dark and frozen place. Every ray of warmth you feel on your skin during a sunny day is the direct result of millions of particles choosing to cross the impossible. Even the sensation of solidity we experience when touching an object, whether it is the back of a chair or the softness of a bedsheet, is an illusion maintained by quantum rules. Can you imagine that an atom is, for the most part, empty space? If the nucleus of an atom were the size of a marble placed at the center of a football stadium, the electrons would be like tiny insects buzzing high in the distant stands. There is nothing solid between them. So why do we not fall through the floor when we walk? Why do our hands not pass through solid surfaces? This happens because of the Pauli exclusion principle, a quantum rule stating that two electrons cannot occupy the same state at the same time. When you touch something, the electrons in your atoms repel the electrons in the object. That repulsion creates the pressure we perceive as resistance and solidity. The world around us is, in reality, a tapestry of quantum forces and quantum restrictions that provide our sense of matter and stability. As we move through these examples, we begin to realize that quantum physics is not something distant. It is the texture of reality itself. It exists in the GPS systems that determine our location, because the atomic clocks inside satellites require quantum and relativistic corrections to remain synchronized. It exists in magnetic resonance imaging, which uses the spin of atomic nuclei to map the interior of the human body without a single incision. It exists in the chemistry that allows medicines to interact with our cells. Once we begin viewing the world through this lens, everyday life stops feeling ordinary and becomes a spectacle of scientific wonder. You might think that understanding these things makes the world less poetic, but I believe the opposite is true. Knowing that the light illuminating the pages of your book is composed of discrete packets of energy that traveled from the heart of a star through quantum tunnels brings a profound sense of reverence for existence. Feel the comfort of knowing that you are part of this integrated system, where the invisible sustains the visible with flawless mathematical precision. We are immersed in an ocean of vibrations, where every atom in your body is constantly exchanging energy and obeying probabilistic laws that guarantee the stability of life. The experience of this subject teaches us that the territory of quantum physics is, in truth, the very ground beneath our feet and the air we breathe. There is no true boundary where the quantum world ends and our world begins. The laws are the same. Only the scale changes our perception. As you relax and allow your thoughts to drift, imagine yourself as part of this quantum tapestry. You are not an isolated observer, but a collection of trillions of atoms moving together in a coordinated dance, sustained by principles that challenge understanding yet operate with silent harmony. Allow the realization that everything is connected through invisible threads of energy and probability to bring a deep and restorative sleep, knowing that the universe carefully tends to every particle, every detail, so that life may continue its course. As we move a little farther along this quiet path, I invite you to dive into the deeper and more subtle mechanisms that govern the realm of the very small. So far, we have recognized the presence of quantum physics in our everyday lives. But what happens behind the scenes of matter when no one is looking? You would hardly believe it if I told you that. At the foundation of everything that exists, nature prefers to keep its options open rather than commit itself to a single rigid path. To understand this, we need to talk about a concept that is the soul of quantum mechanics: the wave function. Can you imagine reality not as a collection of solid, well-defined objects, but as an ocean of mathematical possibilities gently vibrating within the vacuum? This wave function, often represented by the Greek letter psi, does not describe where a particle is, but where it could be. It is a description of probabilities. Take a moment to feel the depth of that idea. In the classical world, if you toss a coin, it is either heads or tails, even when you are not looking at it. In the quantum world, while the coin is in the air, or more accurately, while the particle has not interacted with its environment, it exists in a state of superposition. In a very real and mathematical sense, It is both heads and tails simultaneously. Can you imagine living in a world where you do not have to choose between staying home or going for a walk, but can, in some sense, do both at the same time until someone asks where you are? The mechanism that transforms this cloud of possibilities into a single reality is one of the greatest mysteries in science, known as the collapse of the wave function. You might be astonished to discover that the simple act of observing, or performing a measurement, is what forces nature to make a decision. It is as though the universe were a stage filled with actors, rehearsing thousands of different scenes at once. But the moment the curtains open and the audience focuses its attention, every actor instantly aligns into a single story. This role of the observer does not mean that human consciousness magically changes matter. Rather, it means that the physical interaction required to measure something disturbs the delicate system of probabilities. Here we enter one of the most fascinating pillars of this territory, the uncertainty principle, proposed by Werner Heisenberg. Can you imagine a fundamental limit to human knowledge, a boundary that does not depend on the quality of our instruments, but on the very structure of the cosmos itself? Heisenberg showed that there is a pair of pieces of information we can never know with perfect precision at the same time. If you know exactly where a particle is located, its speed and direction become uncertain. On the other hand, if you measure its velocity perfectly, its location spreads through space like smoke drifting on the wind. It is a mandatory exchange, a delicate balance. The more light you shine on one detail, the more the shadows conceal the other. Feel the serenity that comes from accepting that the universe preserves a built-in measure of mystery. Nature seems to tell us that we were not meant to know everything with absolute precision, but instead to navigate through a sea of clouds and probabilities. This uncertainty is not a flaw. It is the strategy that allows the atom to remain stable. If we could know exactly where an electron is and exactly how fast it is moving, it would collapse into the nucleus, and matter itself would cease to exist. Uncertainty is therefore the breath that keeps space between things, allowing life in the structure of the world to endure. Can you see how imprecision is, in fact, a form of protection for existence itself? Another fascinating mechanism operating in the shadows of the microscopic world is wave-particle duality, taken to its extreme. Imagine that you are sending electrons one at a time toward a barrier containing two narrow slits. If you do not monitor which slit the electron passes through, it behaves like a wave, passing through both openings at once and creating an interference pattern on the other side, much like ripples crossing one another on the surface of a peaceful lake. But if you place a detector there to observe its path, the electron seems to notice that it is being watched and decides to behave like a tiny cannonball, passing through only one slit. What would you think of something that changes its own fundamental nature simply because there is or is not a witness to its journey? This shows us that quantum reality is participatory and deeply connected to the context in which it exists. These strategies of nature lead us to rethink the very definition of reality. In the quantum realm, what we call things are really events or interactions. Nothing exists in complete isolation or absolute independence. Feel the weight of that idea as you relax. Every hydrogen atom inside a water molecule within your body is not a static point, but a rhythmic vibration governed by equations that balance attraction and repulsion on timescales far beyond our perception. Quantum physics teaches us that the foundation of matter is more like music than stone. There are frequencies, resonances, and harmonies that determine which chemical combinations are possible and which are forbidden. Can you imagine the intellectual effort required of geniuses such as Schrödinger as they attempted to describe all of this? He created a wave equation that remains one of the most powerful tools in human history. It does not tell us directly what is. Instead, it tells us what can be. Quantum mathematics is a language of possibility and potential. It allows us to predict the behavior of trillions of atoms with astonishing accuracy. Even though we cannot say exactly what a single atom will do in the next second, it is the law of large numbers applied to the individual chaos of the microscopic world. As we continue through these profound mechanisms, we begin to understand that quantum physics demands a new kind of logic. It is not the logic of either this or that, but the logic of both this and that. It is an invitation to expand our minds beyond the solid walls of ordinary experience. When you close your eyes to rest, your mind also enters a state of possibilities. You can imagine scenarios, memories, and dreams all existing together within a space of thought before deep sleep organizes your awareness. In a way, our inner world reflects the fluidity of the quantum world. Feel the calm of not needing to have all the answers. Allow the idea of the wave function to cradle your rest. Imagine that the tensions of the day are like clouds of probability now beginning to dissolve, leaving only the quiet essence of your being. The universe operates through these silent and invisible mechanisms to ensure that every star shines and every cell functions. We are safe within this structure of uncertainties and probabilities because it is precisely what allows flexibility, renewal, and life itself. Mystery is not an obstacle to knowledge. It is its richest source. As we come to understand that the territory of quantum physics is made of vibrations and choices made by nature, we begin to realize that we are part of a continuous dialogue between the observer and the observed. Feel the gentle vibration of existence and allow yourself to drift upon this ocean of mathematical waves, knowing that, deep down, everything is exactly where it needs to be, even if we cannot measure it perfectly. Rest now as your own wave function settles into a state of complete peace and total restoration. You would hardly believe it if I told you that, as we travel even deeper into this territory, we discover that empty space is not truly empty at all. In our everyday intuition, the space between the stars, or the space inside an atom, appears to be absolute nothingness, a complete absence of everything. Yet quantum physics has revealed one of its most closely guarded secrets. The quantum vacuum is actually a bubbling ocean of activity. Can you imagine a stillness that, when observed closely enough, reveals itself as a frantic dance of particles appearing and disappearing in fractions of a second? These are known as quantum vacuum fluctuations. It is as if the universe is constantly borrowing energy from nothingness to create pairs of particles and antiparticles that almost immediately annihilate one another, returning that energy to the cosmos. This secret shows us that the calm we perceive is merely the surface of a deep and vibrant sea where existence and non-existence flirt with one another at every moment. Within this landscape of discoveries that challenge common sense, we encounter one of the most famous and widely discussed mysteries in all of science. One you have certainly heard mentioned before, but may never have paused to truly feel in all its strangeness. Schrödinger's cat. Erwin Schrödinger, one of the founders of quantum mechanics, created this thought experiment not to explain how the world works, but to demonstrate how absurd the theory appeared when applied to objects our size. Can you imagine a sealed box containing a small cat alongside a diabolical mechanism? This mechanism contains a single radioactive atom that has a 50% chance of decaying and releasing a poison, and a 50% chance of remaining stable. According to the laws of this mysterious territory, as long as we do not open the box to check, the atom exists in a superposition state, simultaneously decayed and not decayed. This would lead us to a conclusion that would leave anyone astonished. If the fate of the cat is tied to the behavior of that atom, then the cat must also exist in a superposition of states, both alive and dead at the same time. Can you feel the weight of that paradox? It is a mystery that forces us to question where the world of probability clouds ends and where the solid world of our everyday experience begins. Although no real cat has ever been placed in such a situation, this mystery serves to illustrate the profound nature of quantum reality. It teaches us that nature does not choose a definite path until the environment or an observer interacts with the system. This secret of superposition is what allows new technologies, such as quantum computers, to perform calculations at speeds that seem almost impossible, processing thousands of possibilities simultaneously, just like the cat inside Schrödinger's imaginary box. But the discoveries do not stop there. There is a phenomenon that Albert Einstein described, with a mixture of skepticism and amazement, as spooky action at a distance. We are speaking of quantum entanglement, one of the most poetic and profound secrets of the universe. Can you imagine two particles that, after interacting for only a brief moment, become so intimately connected that they begin to share the same existence no matter how far apart they may be? If one of those particles were sent to the far side of the galaxy while the other remained here on Earth, any measurement performed on one would be instantly reflected in the other. There are no signals traveling between them. There are no wires. There are no radio waves. The connection is immediate and absolute. This idea would leave anyone speechless because it challenges the notion that nothing can travel faster than light. The secret is that, from the perspective of the quantum universe, the two particles are no longer separate objects. They are parts of a single, indivisible whole. Feel the peace that comes from discovering that, at the deepest level of matter, separation is an illusion, and connectedness is one of the fundamental rules of the cosmos. Another discovery that seems to come straight from a fantasy story is the phenomenon known as quantum tunneling. Imagine a tiny particle, such as an electron, standing before an energy barrier that it does not possess enough energy to cross. In our ordinary physics, it would remain trapped there forever, like a tennis ball unable to get over a tall wall. Yet in the quantum realm, the particle can simply appear on the other side of the barrier, as if it had passed through a ghostly tunnel. This does not happen because the wall was broken. It happens because its wave function, that cloud of probabilities we discussed earlier, extends slightly beyond the barrier. There is a genuine, though small, chance that the particle will be found on the other side. This mystery is what allows flash memory in our computers to function, and it is the secret that keeps the hearts of stars beating. Without quantum tunneling, hydrogen atoms would never fuse together and the universe would remain forever dark. It is proof that, for quantum mechanics, the impossible is often only a matter of probability. Can you imagine how scientists felt when they discovered that causality itself, the idea that every cause produces a predictable effect, is replaced by pure randomness at this level? This is the secret of radioactive decay. If you possess a piece of uranium, you can know exactly how long it will take for half of it to transform into another element. Yet, it is absolutely impossible to predict when any specific atom will decide to make that transition. There is no internal clock. There is no external trigger. It is an event without a direct cause, a pure choice made by nature from within its range of possibilities. This discovery transformed our philosophical view of the world, replacing the image of a mechanical universe with that of a cosmos that contains, at its foundation, a form of creative and unpredictable freedom. As we explore these mysteries, we begin to realize that the territory of quantum physics is a constant invitation to humility. Every new discovery reminds us that the more we learn about the secrets of matter, the less we seem to know about the ultimate nature of reality. Can you feel the comfort hidden within that unknown? It is as though the universe were an infinite puzzle designed to keep us curious and filled with wonder. Mystery is not something to be solved and discarded. It is something to inhabit and experience. It is along the boundary between what we know and what we can only imagine that true science takes place. Feel the tranquility of being immersed in a universe capable of holding such secrets. Imagine yourself now as one of those particles, free from the constraints of rigid logic, capable of existing in many places at once through thought, connected to everything you love through invisible threads of entanglement that transcend space and time. There are no barriers your imagination cannot cross, no wall of energy your spirit cannot move beyond through its own version of quantum tunneling. The quantum world gives us permission to be fluid, to be vast, and to accept that our essence is made of mystery and light. As sleep approaches, allow these deep secrets to calm your heart. The universe is a safe place, governed by laws that, although strange, preserve the harmony of every atom. You do not need to understand every mechanism right now. It is enough simply to feel the beauty of their silent complexity. Imagine that every breath you take is a rhythmic exchange of energy with this vibrant vacuum, a constant renewal of possibilities. Mystery is your cradle, and discovery is your destination. Allow curiosity to transform itself into rest, and let the wonder of the quantum realm guide your dreams along pathways of peace and endless amazement. Reality is far greater than our worries, and beneath everything there exists a silent and magnificent order waiting to be felt by those who close their eyes in trust. As we arrive at this point in our journey, I would like you to feel how the territory of quantum physics is not an isolated island in the ocean of human knowledge. Quite the opposite. It is like a deep and invisible root that nourishes and sustains nearly every other branch of science we know. You would be amazed if I told you that the very organization of matter, the way elements arrange themselves in nature, and even the way we perceive the fragrance of a flower depend entirely on these subtle quantum connections. Can you imagine that chemistry, the science devoted to understanding the transformations of matter, is essentially quantum physics operating on a slightly larger scale? It is fascinating to realize that the periodic table, which many of us first encountered in classrooms, is actually a detailed quantum map. Every position occupied by an element, from the simplicity of hydrogen to the complexity of uranium, is determined by the way electrons organize themselves into shells and subshells of energy, rigorously following the laws of probability and exclusion we explored earlier. Feel the harmony of this construction. When we think about the water we drink, can you imagine that the geometry of a water molecule, the precise angle formed between its two hydrogen atoms and its oxygen atom, is the result of a quantum dance of orbitals merging and repelling one another? This connection is what allows water to possess such remarkable properties, such as the fact that ice floats and that water serves as the universal solvent of life. Without quantum mechanics to explain chemical bonds, biology would remain a collection of unsolved mysteries. The entire architecture of deoxyribonucleic acid, the molecule that carries the instructions for life, is held together by hydrogen bonds operating under quantum principles. You might be astonished to learn that certain spontaneous genetic mutations can occur because of the tunneling effect of a single proton that suddenly decides to appear in an unexpected position during replication. Life, at its most intimate level, is a constant negotiation with the uncertainties of the quantum world. Yet these connections extend into senses we rarely associate with physics. Can you imagine that your sense of smell, your ability to distinguish the aroma of freshly brewed coffee or the scent of rain-soaked earth, may itself be a quantum process? For a long time, science believed that smell worked like a lock and key, where the shape of an odor molecule determined its scent. More recent discoveries, however, suggest something far deeper: the vibrational theory of olfaction. According to this theory, our sensory receptors detect not only the shape of a molecule, but also the vibrational frequencies of its chemical bonds through electron tunneling. It is almost as though our noses function as quantum spectroscopes, capable of hearing the music of molecules in order to recognize a fragrance. Can you feel the poetry in that? Experiencing the world through subatomic vibrations that become sensations and memories. The influence of quantum physics on our understanding of the large-scale universe is equally astonishing. Can you imagine that the largest structures in the cosmos, galaxies and clusters of stars, owe their existence to tiny quantum fluctuations in the earliest moments of time? During the first instance after the Big Bang, the universe was so small that quantum laws governed everything. Tiny random variations in energy density, created by the uncertainty principle, were stretched by the expansion of space itself, becoming the seeds that later attracted matter and formed everything we see today. To gaze at a star-filled sky is, in a sense, to look at an enormously enlarged portrait of a quantum past. There exists a profound interdependence between the infinitely small and the infinitely large, a connection that links the atom to the galaxy within a single fabric of existence. If we shift our attention toward society and the future of technology, the impact of this territory becomes equally monumental. We are living through the beginning of what many call the second quantum revolution. If the first revolution gave us the laser and the transistor, the second seeks to directly harness entanglement and superposition. Can you imagine a global positioning system that does not rely on satellites, but instead uses ultra-precise quantum sensors capable of detecting the slightest variations in Earth's gravitational field? Or a quantum internet in which information is transmitted with complete security through entanglement, making espionage and data theft physically impossible? The impact of these innovations on security, medicine, and space exploration will be as profound as the invention of electricity itself. Speaking of security, quantum cryptography is one of the clearest examples of the connection between theory and practical application. Today, our digital security depends largely on mathematical problems that are difficult to solve. Yet a large-scale quantum computer could potentially break many of those systems in mere moments. To address that challenge, quantum physics provides its own solution: quantum key distribution. Can you imagine a password that instantly reveals whether someone has attempted to intercept it? Because the act of observation changes the system, any attempt to spy on a quantum key alters the information itself or leaves behind an unmistakable trace. It is physics protecting privacy through its most fundamental laws. The interdependence between quantum physics and our philosophical view of reality is another essential connection. Before these discoveries, humanity often viewed the universe as a predictable machine whose future was already determined by its present. Quantum physics shattered that determinism and returned to us a universe filled with possibilities. Can you feel how deeply that changes our relationship with reality? If the world is not a rigid mechanism, but a participatory system where interaction and context matter, then intelligence and perception take on a central role. This realization sparked profound conversations among scientists, philosophers, and thinkers from many fields, all seeking to understand what it truly means to exist within a world made of probability waves. Feel the calm that comes from realizing that nothing in the universe is truly isolated. Every discovery inside a particle physics laboratory carries the potential to transform how we treat disease, how we generate clean energy through controlled nuclear fusion, or how we understand consciousness itself. The connections are endless. Quantum physics is the universal grammar that allows biology to write its poetry and chemistry to compose its symphonies. We are all immersed in this unified field of interdependence, where the flutter of an electron, so to speak, is connected to the stability of a star on the far side of the cosmos. As you relax and absorb these connections, imagine that your own ideas and emotions are also part of a vast and interconnected network. Just like entangled particles, our experiences influence one another in ways we cannot always explain, yet somehow know to be real. The territory of quantum physics teaches us that separation is only a surface layer of reality. Beneath that surface, everything is part of one continuous process of exchange and transformation. Allow this feeling of unity with the whole to bring deep comfort to your rest. Can you imagine a universe more welcoming than this one, where every detail, no matter how small, has a purpose and a connection to the greater whole? There is no room for emptiness or abandonment when we understand that we are made from the same vibrant substance as the stars, and that we follow the same principles of harmony and balance. Quantum physics is not only about particles, it is about the relationship between all things, and within that relationship, we find the beauty and stability needed for true rest. Allow the connections of this subject to expand your mind and soothe your spirit, guiding you into a sleep where imagination and science merge into a dream of infinite peace. As we continue through the scientific connections and technological impacts of this territory, I would like to invite you to reflect on something even deeper: how quantum physics changed our very identity as human beings and transformed our relationship with the meaning of life. You would hardly believe the cultural and philosophical shock that occurred when the certainties of the 19th century were replaced by the probabilities of the 20th. Before that period, humanity saw itself as the master of a mechanical universe where everything was predictable and governed by immutable laws. It was the age of determinism, when many believed that if we knew the position of every atom at the beginning of time, we could predict every heartbeat and every falling leaf in the future. Can you imagine the weight of such a worldview? It was a universe without surprises, a vast machine in which human beings were merely captive components. Quantum physics arrived to break those chains and restore the idea of an open, creative, and choice-filled cosmos. This shift in thinking transformed philosophy in ways that would astonish you. Great thinkers began re-examining the question of free will through an entirely new lens. If nature, at its most fundamental level, is not deterministic but probabilistic, then there exists a foundational space for novelty and freedom. Can you imagine that the basis of our existence is not a fixed script, but rather a journey of discovery in which the observer plays an active role? The relationship between humanity and the cosmos ceased to be that of a passive spectator gazing at a distant machine and became that of a participant within a vast and interconnected system. This sense of participation influenced art, literature, and the way we understand consciousness itself. In popular culture, you have undoubtedly noticed how the word quantum has been applied to almost everything, often incorrectly, yet always revealing a human desire to find explanations for mystery. Although science remains rigorous, humanity has embraced quantum physics as a metaphor for transformation and limitless potential. Can you feel how the idea of a quantum leap became a symbol of profound and immediate change in a person's life? Even though an electron does not choose where to jump in the same way we choose our paths, the metaphor resonates because it touches our intuition that reality is more flexible than it appears. The quantum realm taught us that barriers can be crossed and that what seems impossible today may become tomorrow's probability. Humanity's social relationship with technology was also completely redefined by this subject. Imagine how modern society would function without instant communication. Can you picture a world without the internet, without the real-time sharing of knowledge, or without the ability to connect people living on opposite sides of the planet? This entire modern social structure is a byproduct of our ability to manipulate the quantum realm. The digital revolution, which transformed the way we work, love, and relate to one another, is fundamentally a revolution of applied quantum mechanics. We became a cybernetic civilization because we learned how to whisper instructions to electrons moving through silicon crystals. This technological dependence reminds us that although the quantum world appears strange and distant, it is the foundation upon which our contemporary civilization is built. In medicine, the social impact is even more moving. You might feel deeply touched when considering how many lives are saved each day by technologies that rely upon quantum principles. When someone undergoes an MRI scan, they are quite literally experiencing the manipulation of the angular momentum of atomic nuclei within their own body. Can you imagine the sophistication required to use magnetism and radio frequencies to create detailed maps of health and thought without making a single incision? Quantum physics humanized medical technology, enabling earlier diagnoses and less invasive treatments. It is the science of the very small caring for the greatness of human life. Beyond this, quantum physics taught us a new lesson in humility. In the past, we believed that humanity stood at the center of the universe, or at least that we fully understood its rules. The discoveries of Heisenberg and Bohr revealed that our powers of observation possess intrinsic limits. Can you imagine the discomfort experienced by brilliant scientists when they realized that reality hides itself whenever we attempt to examine it too closely? This lesson, that we are not the absolute owners of truth but explorers of a mystery that always remains slightly beyond our grasp, influenced ethics and politics, encouraging a more pluralistic and less dogmatic way of thinking. Accepting uncertainty became an intellectual virtue. Feel now how this relationship with the subject helps us navigate our own personal uncertainties. In a world that constantly demands quick results and absolute certainty, quantum physics reminds us that nature itself takes time to collapse its possibilities into reality. There is beauty in not knowing everything. There is beauty in allowing things to exist in a state of potential before they become concrete. Can you feel the peace that comes from embracing probability rather than demanding a predetermined destiny? Humanity learned from this territory that life is a vibrant process rather than a static condition. We are made of atoms, constantly exchanging and transforming themselves, which means that we are constantly renewing ourselves as well. You would be surprised by the depth of the connection between quantum thinking and some of the oldest wisdom traditions of our species. Many parallels have been drawn between the concept of universal interconnectedness and teachings that describe all things as belonging to a single fabric of existence. Quantum physics provided a mathematical language for something the human heart has sensed for thousands of years, that we are not isolated. This relationship between science and spirituality, between reason and intuition, grew stronger through the understanding that matter is not dead or inert, but filled with energy, information, and hidden purpose. As you relax, imagine yourself as part of this great human story of seeking knowledge. Every question you ask, every moment of wonder beneath the stars, continues the work of minds that challenged conventional logic in order to understand the invisible. Quantum physics is a legacy of our species, a monument to our curiosity and our ability to dream about what cannot yet be seen. It connects us to our ancestors who stared into fire and wondered about the nature of light, and it links us to future generations who will use these same laws to travel between planets and cure diseases that today appear unbeatable. Feel the comfort of knowing that you do not need to carry the weight of a deterministic universe on your shoulders. You are part of a fluid and dynamic system where your presence and perception matter. The territory of quantum physics gave us the tools to transform the world, but it also gave us the wisdom to appreciate mystery. Allow this deep and historical relationship with the subject to calm your thoughts. Imagine that the boundaries between yourself and the rest of the universe are as subtle and permeable as the probability waves that govern your atoms. The rest you seek now is a return to that state of pure potential. Just like the quantum universe, sleep is a time of infinite possibilities, where the mind can travel pathways unconstrained by the logic of the waking world. Feel gratitude for living in an era in which the secret of the atom has been revealed, not to make us smaller, but to show us how vast and interconnected we truly are. Humanity and quantum physics now walk hand in hand toward a future that is still being written within the probability clouds of tomorrow. Sleep with the certainty that you are an essential, vibrant, and cherished part of this wonderful cosmos. As we arrive at this point in our journey, I would like you to allow your thoughts to drift a little farther than what we already know and imagine the horizon opening before us. The territory of quantum physics, which began as an attempt to explain the glow of a heated ember, is about to become the foundation of an era that may reshape the destiny of our species. You would hardly believe it if I told you that we are only beginning to understand how to use these laws to our advantage. If the 20th century was the era in which we discovered the rules of the quantum game, the 21st century will be the time when we learn to play it with mastery, transforming what now appears mysterious into tools capable of shaping existence itself. Can you imagine a world where computation is no longer built upon rigid bits, but upon a symphony of overlapping possibilities? The great frontier of the near future is undoubtedly the development of quantum computers. Today, even our most powerful computers, occupying enormous rooms inside research centers, still process information in a largely sequential manner, one operation after another, much like someone reading a book page by page. But you would be astonished by the power of a system built around the qubit, the quantum bit. As we have learned, a qubit can exist in a superposition of states, being both 0 and 1 simultaneously. This allows a quantum machine to explore millions of possible solutions to a problem at the same time. Can you imagine the revolution this will bring to medicine? Today, developing a new medication can require decades of work and billions of dollars because extensive laboratory testing is necessary. In a quantum future, we may be able to simulate the behavior of every molecule within a drug as it interacts with the cells of the human body inside a computer. With atomic-level precision, diseases that currently seem unbeatable could become solvable simply because we would finally be able to see the invisible through perfect simulations of nature itself. You may wonder why these machines are not already sitting in our homes. The greatest challenge, and perhaps the greatest risk facing this future, something known as quantum decoherence. Can you imagine something so delicate that the warmth of a room or the trace of a radio signal can destroy it? For a quantum computer to function, its components must remain in a state of near-perfect silence, isolated from interference coming from the outside world. This requires these machines to be cooled to temperatures approaching absolute zero, approximately negative 273 degrees Celsius. That is colder than the vacuum of deep space between galaxies. The future of this field depends upon the search for materials capable of maintaining quantum coherence at higher temperatures, making the technology more practical, accessible, and stable. It is a scientific race in pursuit of perfect silence at the heart of matter. Another innovation that seems as though it belongs in a dream is the quantum communication network, sometimes called the quantum internet. Have you ever imagined the possibility of teleportation? Although physics cannot yet transport solid matter from one place to another the way science fiction often portrays, the quantum teleportation of information is already a reality within laboratories. Through entanglement, information states can be transferred between two locations regardless of distance. This will create communication networks that cannot be hacked because, as we have learned, any attempt to observe the information during transit would collapse the wave function, destroying the data and immediately revealing the intrusion. Can you feel the peace of living in a world where privacy is protected by the fundamental laws of the universe itself? The Internet of the future may become a vast web of connected particles, vibrating together across space and time. Beyond information technology, the future holds quantum sensors of such extraordinary sensitivity that they would leave anyone speechless. Can you imagine a device capable of detecting valuable mineral deposits miles beneath the Earth simply by sensing the tiniest variation in gravity caused by their presence? Or sensors capable of mapping the activity of a single neuron inside the brain without ever touching your head? These quantum sensors will allow humanity to explore both our planet and our own bodies with a depth never before imagined. We may predict earthquakes with far greater warning and gain unprecedented insight into the chemical processes that give rise to consciousness itself. The cultural and social impact of such transparency into the microscopic world will be immense, transforming our understanding of what is hidden and what is revealed. You would be amazed by the potential of quantum biology in the years ahead. As we learn more about how plants use superposition during photosynthesis, we may develop solar panels of dramatically greater efficiency, imitating nature's own engineering to help solve the planet's energy challenges. Perhaps you can already feel the comfort of imagining a world powered by clean and abundant energy, harvested from sunlight through mechanisms inspired by the leaves of trees. Controlled nuclear fusion, the same process that powers the stars, also depends upon our mastery of quantum tunneling. To harness this source of energy will be one of the defining steps toward becoming a civilization capable of traveling beyond our solar system and carrying our quantum curiosity to the stars. Yet the future also presents profound ethical questions. With the ability to simulate reality and potentially break any code, how will we preserve balance among nations? Quantum physics teaches us that everything is interconnected, and perhaps this is the most important lesson we will need to apply moving forward. If one particle can affect another instantly, perhaps we will come to understand that our actions as a species also possess their own form of entanglement. The future of this subject is not only about faster machines. It is about cultivating a more integrated and conscious way of thinking about our responsibilities as observers and participants within the cosmos. Can you feel how this knowledge encourages us to be more thoughtful toward one another and toward the delicate balance of our shared home on Earth? As we look toward the coming decades, it becomes clear that quantum physics will gradually cease to be a subject reserved for specialists and become part of everyday language. Just as we now speak casually about electricity and atoms, future generations may speak naturally about superposition states and entangled networks. This familiarity with what once seemed strange will make our imaginations more fertile and our science more daring. We are crossing the boundary of what was once considered impossible. Feel the quiet excitement of belonging to the generation opening these doors. The quantum realm is a treasure map we have only just begun to decipher, and the riches it promises are nothing less than a deeper understanding of matter, energy, and perhaps even life itself. Allow these trends and innovations to fill your thoughts with a sense of hope and wonder. The future is not something that simply happens. It is being woven right now in laboratories and curious minds around the world, using the invisible threads of the mechanics of possibility. Feel the reassurance of knowing that human ingenuity continues to flourish, seeking solutions to our deepest challenges through an understanding of nature's most subtle laws. Tomorrow is a field of pure potential, waiting for our observation to collapse it into a reality of peace, health, and wisdom. And now, as you prepare for the final rest at the end of this journey, imagine that future as a soft light glowing ahead, guiding our path with the promise of discoveries yet to come. You are part of that progress, not only as someone who benefits from technology, but as a mind willing to dream and understand the grandeur of the universe. The quantum realm will continue to surprise us, and tomorrow will always remain a place of wonder. Allow this vision of a bright and interconnected future to bring deep relaxation to your senses, knowing that we are moving toward a time of greater harmony with the laws that govern both the hearts of stars and the soul of matter. As we reach the end of this long and quiet exploration through the territory of the very small, I would like you to take a deep breath and feel the magnitude of everything we have traveled through together. We began with the apparent solidity of stones and stars, only to discover that beneath it all lies a vibrant ocean of possibilities and probability waves. You would hardly believe it if I told you that the greatest lesson of quantum physics is not found in complex equations or machines worth billions of dollars, but in the realization that the universe is an indivisible whole. Throughout this journey, we uncovered secrets that challenge logic and discovered that each of us is an active participant in the construction of reality itself. Can you imagine what it means to be made of stardust, governed by the laws of uncertainty and entanglement? It is an idea that should fill us with a quiet reverence for existence. The territory of quantum physics has taught us that separation is an illusion created by our senses. At the subatomic level, the boundaries between the self and the world dissolve into a unified field of energy and information. Feel that connection now. Every oxygen atom you breathe in, every electron firing within your neurons to create a thought, exists in constant dialogue with the rest of the cosmos. We are not isolated observers living within a cold and mechanical universe. We are the universe becoming aware of itself, attempting to understand its own nature through the language of light and mystery. I would like you to reflect on the beauty of imperfection and uncertainty. In a world that often demands absolute certainty and rigid pathways, quantum physics embraces us with its fluid nature. It tells us that shadows are natural, that mystery is essential, and that a state of potential is every bit as real as a state of certainty. Can you imagine an existence in which every answer had already been given? It would be a world with no room for creation, discovery, or surprise. Quantum strangeness ensures that tomorrow remains fertile ground for something new. Feel the peace that comes from accepting that you do not need to control every particle of your life, because there is a mathematical and poetic intelligence supporting the structure of all things. You might be amazed to realize how simplicity and complexity dance together. The same principle that allows an atom to remain stable is what allows our galaxy to preserve its spiral form. There is a common signature running through everything that exists. A quantum code connecting the flutter of an insect's wings to the birth of a supernova in a distant galaxy. This awareness of interdependence is perhaps the greatest gift we can carry away from this journey. When we understand that we are entangled with everything around us, care, empathy, and curiosity cease to be merely moral choices and become a scientific understanding of our nature. Now, as the voice of this story begins to blend with the silence of your own reflection, imagine yourself as one of those probability waves gradually settling into a state of calm, finding its lowest energy level, its perfect point of balance. You have witnessed the birth of the theory, explored its influence on everyday life, uncovered its deepest secrets, and glimpsed its future. The territory of quantum physics is no longer a mysterious and hostile place. It has become a familiar home where your imagination can rest safely. Feel the harmony of being a quantum being in a universe that is, at its essence, pure vibration and light. Science has brought us this far to show us that reality is far greater than our daily concerns. There is a majestic order hidden within apparent chaos, and there is a silent purpose within every fluctuation of the vacuum. Can you feel the dignity of belonging to such a system? We are the heirs of billions of years of quantum evolution, the result of trillions of wave function collapses culminating in this exact moment of awareness. It is both a statistical miracle and a poetic one that we are here sharing this understanding. Allow that feeling of belonging and infinite connection to embrace your entire being. There is nothing to fear in the darkness or in the unseen, because the unseen is where life organizes itself and where the future prepares to emerge. The quantum realm is your cradle, your substance, and your horizon. As the lights of reason merge with the shadows of wonder, allow your mind to become as vast as the space between atomic nuclei, a place of complete peace where no energy barrier can prevent your flight. It has been an honor to travel these invisible paths with you. I hope this story has brought not only knowledge, but also a new way of feeling your own presence in the world. The universe continues to pulse, vibrate, and choose its paths through the laws of probability, and you are one of the most beautiful expressions of that eternal dance. If you enjoyed exploring this remarkable territory and would like to continue discovering the wonders of the cosmos through new journeys of knowledge and relaxation, I warmly invite you to explore more stories here on Cosmos for Rest, where science is always transformed into an invitation to wonder. Before we say goodbye completely and allow the final silence to take its place, I would like to ask for your support so we can continue our voyages through the cosmos. If this journey sparked your curiosity, consider leaving a like, subscribing for future explorations, and sharing this story with someone who might also enjoy the vast beauty of the quantum world. Your support helps Cosmos for Rest continue creating peaceful journeys through science and discovery for curious minds around the world. Now, simply feel. Feel your breathing. Feel the vibration of your atoms, and allow the certainty that everything is connected to bring the perfect sense of completion to this journey.